Okay, this is the second recording for 3.3 and 3.4. Today this section is just going to be solving a few simple exponential and logarithmic equations. When given a situation where it is possible to put excuse me, our logs on either side of the equal sign, it is easiest to do this because now we can use our one-to-one relationship and show that x is equal to 9. Simple, easy. Now here we have to do a little bit more of algebra. So we're going to cross multiply. We get 400 equals 300, 1, oops, there's a minus in there, e to the minus x. Now if I divide by 300, these 300s cross out. Hopefully you realize the hundreds will cross out. I now have 4/3 equal to 1 minus e to the negative x. I'm going to subtract 1 from both sides. I get 4/3 minus 1 written as a 3/3. Pardon me, this is 1 over 3. It's going to equal negative e to the negative x. Now after multiply through by negative 1, I get negative 1/3 equals e to the negative x. At this point in time, I'm going to take natural log of both sides so that I can get rid of the e. Sorry. So hopefully you notice at this point that I have a natural log with a negative number inside. Remember we said you can never, ever, 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 never, 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 no, not ever, ever, never have a negative inside. So this means there is no solution to this problem. But you might not have recognized that. So let's take it the next step. So if we put this then in our calculator, the natural log of negative 1/3, you're going to get a no sign change or some weird error like that. What I would hope you would do is get that on your calculator and go, why might that be? And go look at your math, double check, make sure it truly is a negative 1/3. Yep, my math all worked. Now, why can't I do that? Why is the negative? Oh, negative. That's right. Mrs. Cronquist said we can never, ever, ever, no, ever, ever, never, never, ever, never, no, never have a negative inside of a log. That's right. So that means no solution. Okay? Alright, so let's go look at the next slide. Here, we're going to ignore this because that's actually supposed to be for the previous one. Alright, here I have one natural log on one side and 2 on the other. Well, what I'm going to do is I'm going to condense the side that has 2 so I have 1 and 1. Then I can do my one-to-one property. So this is going to give me natural log of x plus 7 equals natural log of x minus 2 over x plus 2. Notice it's a subtraction where I divide them. Sorry, I've got a little tickle in my throat. One-to-one property means I now have, whoa, not that. One-to-one, are you kidding me? Come on, silly thing. Means I now have x plus 7 equals x minus 2 over x plus 2. I can do a cross multiplication because I have an equal sign. X plus 2 times x plus 7 equals x minus 2. So I'm going to FOIL. I get x squared plus 9x plus 14. Okay, now since I have the x squared, I know I'm going to have to FOIL. So I'm going to have to move the x and the minus 2 over to the other side. So 9x minus 1x is 8x. 14 plus 2 is 16. And I factor that. Factors of 16 that add to 8 would be 4 and 4. So that means my x is equal to negative 4. You know what? There is no solution to this one. I misled everybody, didn't I? Remember what we said about no negatives? Look, if I put this in here, I'm going to get the natural log of negative 6. Can't work. This one actually does have no solutions. There we go. Alright, so now let's look at our in-class practice. Okay, so these should be your answers. You should be able to put a lot of them in your calculator. This one you ended up with 2 answers. It was just like the last one we did, but there's a negative 8 answer that doesn't work because there's also a natural log of x, and if I plug in negative 8 to the natural log of x, I get natural log of negative 8, which I can't not ever, never have as a inside my log. So that's why it's only the 6. Alright.